everybody. And in our last session, we did some problems on writing numbers in loose form and tight form using place value. The last session was not about fractions at all. It was not about decimal fractions. It was about place value and about understanding how to convert from a loose form to a tight form using place value notation. Now, let's come to decimal fractions with a bit of revision from where we had taken a break, not in the last session, but in the last to last session. Recall, we had introduced the concept of a decimal point, which is just a guide to telling us which is the ones house and which is the house of 1 by 10. Once you know which is the house of 1 and the house of 1 by 10, then all the other houses you can also know just in sequence. So now let us begin. Recall that we wrote this number with 1 in the house of 1s and 5 in the house of 1 by 10s. We wrote this as 1.5. The decimal point tells us that this is the house of 1s and that this is the house of 1 by 10. So here 1 in the house of 1s and 5 in the house of 1 by 10 becomes 1.5. So now Gyan Jyoti, take a fresh slate. I am showing you a number written in the houses. You have to write the number using the decimal point. So write this number here. That's right. And the next number, that's correct. How will you read the numbers that you have written?
24.3.
And the next one?
102.5.
102.4. Right? So decimal point is nothing really new. It is just a way of saving time, so we don't have to write houses. But decimal fractions is basically about writing the houses not only for 1s, 10s and 100s, but also for 1 by 10, 1 by 100, 1 by 1000 and so on. That's all there is to decimal fractions. And when you can write a fraction in the houses of place value in powers of 10, this is known as powers of 10, that is what is decimal fractions. But now that we know how to make and write decimal fractions, we can start using decimal fractions for making measurements. And today what we are going to do is do some experiments for which I have to make some equipment. Remember, we had made fractions kit, and there our one was a rod of 12 centimeters. But now I want to make a rod of 10 centimeters. So Gyan Jyoti, can you take a rod of 12 centimeters and make a 10 centimeter rod? Okay, show that to the camera. All right. And using broomsticks, remember we took broomsticks and we could break them at different lengths. So can you show a broomstick which is of the same length? Just hold them together to the camera, show that they are the same length. So now hold the broomstick in your hand. What is the length of that broomstick?
10 centimeters.
10 centimeters. So now I want you to take 10 such broomsticks and put them end to end. So make 10 plus 10 plus 10, 10 times on the table. Okay. So now you have put 10 rods, each of them is how long?
10 centimeters.
10 centimeters. So that whole length which you have made, that is how many centimeters?
100
100
centimeters.
centimeters. And we know what is 100 centimeters called?
1 meter.
1 meter. So I want you to take now that bamboo stick, bamboo strip, which is in front of you, keep it very accurately next to and mark out 1 meter. I think do it from the other side. Yeah, turn it around so that use that as the beginning. Okay. And on that side, on the other end, mark out the point, which is, mark that with a pencil, with your pen. Okay. And now can you cut the rod at that point, cut it or break it? Accurately. Okay, now break it. After cutting it a little bit, break it. All right. Okay. So now, how long is that rod which is in your hand?
1 meter.
1 meter. So now, if that is 1 meter, take a broomstick in your hand, the broomstick. If that rod, keep the 1 meter rod in front. Yeah, keep that in front of the table. That is 1. And in your hand, if that is 1, what is in your hand? If that is 1 meter, what is the length of the rod in your hand in meters? How many such rods are there in 1 meter?
10.
There are 10 pieces like this. There are 10 pieces like this in 1 meter. So if there are 10 pieces in 1 meter, how many meters is this?
1 by 4.
1 by
4.
4. There are 10. There are 10 such pieces.
1 by 10 meter.
1 by 10, right? So this is 1/10 of a meter. Okay. Now if I divide this into 10 pieces, now remember this is 1/10 of a meter, but this is 10 centimeters. So 1/10 of a meter is the same as 10 centimeters, right? Now if I divide this into 10 equal pieces, so let me say that this is one piece now, just for example. So if that was 10 centimeters, how much is this?
1 by 100.
1 by 100 of a?
10
Of a?
10 centimeters. 1 by 10.
Just a minute. Show that rod in your hand, the big rod. That is what is the length of that?
1 meter.
1 meter. If that is 1 meter, then this is
1 by 10.
1 by 10 meters. And this is
1 by 100 meter.
1 by 100 meters. Very good. So that is 1 meter, this is 1 by 10 meters, and this is 1 by 100th of a meter. But remember, if it in meters, it is 1 by 10, and 1 by 100. If you look in centimeters, then what is the length of that big rod? In centimeters? 100 centimeters. How much is this?
10 centimeters. 10 centimeters.
10 centimeters. Right? That big rod is 100 centimeters, and then these pieces are 10 centimeters. So how much is this?
1 by 10 centimeters.
This is 10. This is
1 centimeter.
1 centimeter. So 1 centimeter, 10 centimeters, 100 centimeters, or 1 meter, 1/10 of a meter, 1/100th of a meter. Depends on what is your unit. If your unit is centimeters, then this is 1, this is 10, that is 100. If your unit is meters, then that is 1, that big rod. This is 1 by 10, and this is 1 by 100. Okay? So now the problem that I'm going to give you is to measure the length of that table using your meter rod. So is the table more than a meter or less than a meter?
More than a meter.
More than a meter. But if I take 2 rods, that will be how much? 1 meter and 1 meter, that will be?
2 meters.
2 meters. So is the table more than 2 meters or less than 2 meters?
Less than 2 meters.
Less than 2 meters. It is more than 1 meter, and it is less than 2 meters. I want to measure the length of the table. So I can't now use meters, so I will have to go to
Centimeter.
this, 1/10 of a meter. So now add So how much is that? Is it exactly at the end? Is it more or less?
Less.
It's less. Okay. Is there still some space at the end? All right. But now if I put one more rod, then will it be bigger or smaller? That hole?
Bigger.
to be bigger. So now let me so we have 1 meter, and then how many pieces of 1 by 10?
2.
2 pieces of 1 by 10. So I'll write that here, but there still is some space left. So can you fill that space with the pieces of which you had made? Remember, you had made those pieces. Show those pieces. Not those. I think you had cut from the piece of paper. You had cut 1 centimeter pieces. So make some 1 centimeter pieces. Very good. And then can you keep those at the end and see how many pieces are there? How many pieces will fit? You can stand up and do it.
1 piece.
Just 1 piece. Keep it there. Okay, now keep the whole thing very carefully. That meter rod and the pieces of 1 by 10, just keep them end to end very carefully. Start from here. Are you sure that it is end to end correctly? No, not that. Your meter rod, is it exactly touching the end of the table?
Yes.
Exactly? Okay, now on the other side, put your pieces of 1 by 10. Have you reached the end of the table?
No.
There still is some space. What can you put in that space? Put something in that space. Fill up the space exactly to the end. Is there space for 1 centimeter there?
Yes.
There is. Keep that 1 centimeter there. Have you reached the end?
No.
Is there space for 1 more? Is there space for 1 more centimeter? There is. Okay. Keep 1 more centimeter there. Is there space for 1 more centimeter?
No.
No. So keep all your pieces there, end to end. So 1 meter, 2 pieces of 1 by 10, and 1 by 100 have you kept? So how many pieces of 1 by 10?
2.
2. How many pieces of 1 by 100?
1.
1. So now let us make the houses. So how many pieces of 1 are there?
1.
1. How many pieces of 10?
0.
0. How many pieces of 100?
0.
0. How many pieces of 1 by 10?
2.
2. And how many pieces of 1 by 100?
1.
1. So can you write this using decimal point? So that is 1.21 meters. Let me just go and see how accurately the measurement is made. This is 1 meter, and here we have 10 centimeters, and here we have another piece, but actually, Jyoti, I think there was not enough room for two pieces. This the second piece is actually outside. So let's see how much outside it is by putting these pieces here. These are 1 centimeter pieces. So it is one piece and still some more. Here is another piece here. So actually it is two pieces less, right? So if this is 100, then this is 1 by 10, and here there's not enough room for 1 by 10. So let's see, we can't use this because this is too big. So let's use these pieces here. Can you make some more pieces and give me? And I'll keep them here end to end. So one piece, two pieces, three, 4, 5, 6, 7, and just enough space for one more, which is 8. So there is 1 meter, one piece of 1 by 10 meters. And how much was this?
1 centimeter.
1 centimeter. In meters, this is 1 by 10, this is
1 by 100.
1 by 100. So how many pieces of 1 by 100 do we have?
9. Sorry.
8. Okay, so please write in your house. In your house of, here you have house of 100, 10 units, 1 by 10, 1 by 100. So you have one of these. How many pieces of this? One of these. And how many pieces of 1 by 100? 8. And can you write that in decimal point now? So what you wrote earlier, 1.21, actually that was too big, right? Now we have done it more accurately. So what will that become? 1.18. Because this is 1 unit, 1 piece of 1 by 10, and 8 pieces of 1 by 100. Okay? So this is what we have done today. We have started measurement, and maybe there was a little bit left. So for that we have to go to pieces of 1 by 1000. This is 1 by 10, 1 by 100, and then for the little piece 1 by 1000. But that we will do next time when we go to, this is 1 meter, 1/10 of a meter, 1 centimeter, and then that 1,000th of a meter is known as 1 millimeter, which we will discuss later. So this is where we will take a break today, and when we go ahead, we will discuss about addition and subtraction of decimal fractions. Thank you.